question here. All right, so Mr. Kurdi right here. Okay, so this guys will be part of our exercise. This one. Okay. And then yes. Okay, here we go. Let you in the system. We're up and running. Yeah, mine here. Okay. Any question, guys, about the adjustable circuit breakers? What I'm going to take now, I'm going to take an example that will be in your calc. This is a calc example. So if you guys go ahead and start right here. Here's what I would like you to do, guys. For this circuit breaker, the 3200 example that you have, we're going to calculate the long time pickup, short time pickup, instantaneous, and so forth. One more time. For this adjustable circuit breaker, I would like you guys to do to calculate the long time pickup, short time pickup, instantaneous, and delay, and so forth. So let's go ahead and start. The first thing I would like to do is find for this adjustable circuit breaker long time pickup in amps. In order to get you, and I'm going to give you some time to write, guys. This will be on our test 4, and this also will be on our final. So that I need you guys to do it by hand, and then we'll do it by computer. The only thing I'm going to give you, Chris, is this value. This value is given. Chad Kurdi, decided to set this circuit breaker at 0.5. So can you guys write this? I know I didn't give you that. So remember that circuit breaker that we talked about, that you have a copy about it? The setup, I decided to set the long time pickup at 0.5. Okay, the long time pickup, I decided to set it up at 0.5. My question for you, Chris, is what is the amp setup for long time pickup? Okay, the long time pickup, I went with a screwdriver, grabbed it, and I adjusted to 0.5. Cool. My question for you is, what is the long time setup in amps for this circuit breaker? In amps, not in percentage, in amps. Here's the formula that you're going to be using. It's going to be a 0.5, which is the setup. You're going to multiply this one by the plug amp for this circuit breaker. And Chris, this is basically the setup multiplied by the plug amps. So the rule is, whatever is your long time pick up, you multiply this value by the plug amps. Cool. So this is anything in black is the formula. So long time pickup, if you guys look at the sheet that you have, if you look at the sheet, please, I gave you, the plug amp. What's the plug amp, Chris? What's the plug amp? The plug amps for the circuit breaker that we just looked at here. Thank you. Plug size in amps is 1,000 amp right here. Plug amps is 1,000 amp. Everybody got that one, guys? With a plug amp. The plug amp, you have this picture, is 1,000 amp. I picked up 1,000 amp plug. Okay, so a piece of cake. You're going to take a 0.5, multiply it by 1,000, and that will get you, yes, sir.
What is equal to LTP times plug in?
The long time, what's equal all this?
Yeah.
The long time pickup. Long time pickup in amps. That's what we're trying to find.
0.5, what? 0.5 seconds?
That's sitting. No. That's just, yeah, it's a percentage. Yeah.
What
Yeah.
I'm talking is the formula. The formula you know,
Yes.
something must be equal to that.
Long time pickup in amps is equal to long time pickup in amps is equal to long time pickup sitting. Let me use that one. Alanibo, let me write it this way. Okay, here. Let's just write it in a better situation. Okay. let's say this, long time pick up amps, cool, equal to long time pick up setting multiplied by plug amp in amps. Does that make sense?
Yeah.
This is the formula. Much nicer, much better. Hello, boy, you a quality guy here? Okay, so that's the formula that you need. All right, so let's go apply the formula. Long time pick up amps in amps equal the long time pickup. Chris decided to the long time pickup at 0.5. He decided to put 0.5. It could be any number from 0.1 to 1. Multiplied by long time, the plug-in amps. Everybody knows that the plug is 1,000 amp. I just looked at it, 1,000 amp. If you guys do that, this will give you a 500 amp. Now, Chris, for all practical reasons, this circuit breaker have just turned into a 500 amp circuit breaker. Now, who cares? Who cares? Let me tell you who cares. Now, I'm going to take the same circuit breaker that we were looking at, and I'm going to draw the one line, the riser for it. I'm going to show you a few things. I'm going to show you frame size, this F size they call it. The frame size for this breaker was 3200 amp. I'm just repeating the information, guys, that I gave you on the fair sheet. Okay. Plug size, P size is the plug size, was 1,000 amp. Okay. Now, long time pick up size is 500 amp. Okay, now Ashley, you're looking at a circuit breaker like this. Which amp are you going to use to size the cable? I want you guys to tell me right here. I have a cable here. Which size are you going to use to size the cable? I have the frame size, the plug size, and the long time size. Which one are you going to use to size the cable? What? 500 amps. See how that's how powerful that is? That's how powerful circuit breakers, guys, power circuit breakers are. It turned a 3200 amp into a what? A 500 amp. So the value that you're going to use to size everything as 500 amp. Okay, so let's go do that. Let's pull full neutral. So Chris, if this is a full neutral, I need 4 conductors. What size based on 3 10 to 16? Number 600, 700, more than that. Anybody can quick give me a circuit breaker that can carry 1 conductor. We don't want to pedal. Just for this sake, we're going to just put 1 conductor. 900. Thank you. 900 kcm. Done. Do you see how powerful that long time pickup in amps is? That's how we size the conductors based on the long time pickup in amps.
Is that new reason for no filing?
No, it's just because I'm lazy. I don't want to pedal. If we pedal the 2 sets of Chris, Nick, what's 2 sets of for pedaling him? So a lot of boys is happy. Okay, 2 sets of 4 conductors. Each one of them is 250 kcm to please my friend Alaribo here. Which is actually a better pedaling is a better way to just for you. Yes, sir.
The plug size.
Oh, where did it come from?
What? No, I know where it came from on the diagram, but I don't know what it is.
Oh, the plug size is in the face of the circuit breaker. It's an what is it? It's an electronic device that's rated to a max. Actually, really, it's an electronic circuit. Probably, literally, it's a size. Imagine a size of 4" by 4" by probably 6" cube. You can plug it into the face of the circuit breaker. There's a slot for it in the face of the circuit breaker. You can plug it into the face of the circuit breaker. Based on this electronic circuit, your circuit breaker can be one size or another.
What gives you the range? 10% increments, 100%, 500, 1,000, 0.5 or 50%, 500.
Okay, so we could really change out our plug to go higher for our frame size.
Ah,
Or lower.
Yeah, your limit, thank you. The plug size, the limit for the plug size is the size of the frame.
Yes.
You can't go higher than the frame because physically you can't fit. That's the only limit. So I can get based on the manufacturer. I think the one that I told you guys, it was here. Here's the frame. The if it's a 4,000 amp, it's right. Actually, was it here? No, not in this. Okay. Um, there were sizes. Yeah, based on the manufacturer, you might have 800, 1,000, 2,000 right there. The last column on page 20. What was it, guys? Right here. 26.7. 26.7. The last column, guys, adjustable plug-in. The plugs for a 4,000 amp, it's actually going to be .18. Your options are 2,000. You don't even have 1,000 on this type of circuit breaker.
Oh,
Yeah.
wait.
Don't worry.
Why don't we use the 3,200 frame size?
We can. I decided I don't want to use it. Okay, the rule is, here's the rule is, guys, can I have your attention for a second? Chad, why the heck did you come up with these readings? You're asking, this is just an exercise. What did you come up with this reading? What reading do I need is what is the circuit breaker size that you came up with. So you came up with 500 amp circuit breaker, right? That's what I need. Then, based on this type of circuit breaker, I'm gonna pick a frame and bring that's more than 500, obviously, a size that's equal or more than 500, and a setting. So ultimately what decides what size you need is what you load. How do you calculate your loads? I'll show you when we do the exercise. Okay, any question, guys, about the long time pickup? So please, on the test, you need to write this black one as a formula. You get the settings and the plug-in. What do you need to do? You need to find the plug-in in amps. Okay, so we found the long time pickup. Let's go find let's go find number 2. It's going to be the short time pickup. Number 2 is a short time pickup. This is before I move, Nick, everybody understand that this value is the overload value, right? You can't go higher than 500 overload. Okay. Now let's go closer to the ground fault. Now this short time pickup is always the formula. We'll write this one down. I'm going to write this formula. Here's the formula. And like a lot of people said, what is this equal to what, Chad? Long time, short time pickup in amps equal to short time pickup in amps equal to let me use the setting here. The setting, make it as a formula. Short time pickup setting, okay, multiplied by long time pickup. Amps. Can you guys write this? So short time pickup in amps equal short time pickup in setting. That's the one now in the dial, multiplied by long time pickup in amps. Now you are a bunch of engineers when you start talking about this language, setting and the plugs and all that stuff. I was so excited, guys, to see Nick, one of you, because this is usually engineers are touch this stuff, but I'm really excited that Michelle is opening it for a lot of designers. It's really good. So you can have a future doing all this analysis and so forth. We're not wasting our time, I hope. Okay, can you guys write the formula? Alaribo, quality, short time pickup in amps, which is the short circuit, the ground fault, equal the short time pickup that you have to set. So I'm going to pick on Chris. Chris decided to set this one 15 based on the coordination. And the formula is you multiply it by long time pickup. Okay, let's do the math. That's piece of cake, right? So what's the setup? 15 given multiplied. What's the long time pickup in amps, Nick? We just calculated it.
I think it was 500.
Thank you, sir. 500. And what do you guys think this will give me? 7,500. 70 and 7.5 kiloamps. I like you guys to do these in thousands. Divide this by 1,000. When you start talking about short time pickup and short time pickup is always in 1,000, right? Everybody knows now. Did I put the 1,000 in the settings there? I did not. Because if you put the answer 7,500 amps, is it wrong? No. Typically, these are given in thousands. Short time pickup, get used to them being in thousands, right? Should I put 1,000 here so make it? So I'm going to add here 1,000. Can you guys put 1,000 here? Right at the bottom of this, 1,000. Okay, so 7.5. What this says, if I have a ground fault or a low short circuit, low current short circuit up to this value, the one that's going to trip that circuit breaker is that segment. Okay, piece of cake. Second one. Any questions about short time pickup? Short time pickup. Okay, and everybody knows where the short time pickup component is. Let's go back to the short time pickup. What we're sizing is, this is the long time pickup, right? Right in here. Now we size the short time pickup, which is right in here, right? Long time pickup, short time pickup. We size these two. Now we're going to go size the short time delay and the long time delay. Short time delay and long time delay. Cool? Okay. Short time pickup. Okay. Before we do that, we're going to do the instantaneous. Yeah, let me go to the instantaneous. The instantaneous, Chris, is right this little piece here. I want to size this piece. So here's 1, here's 2. These are my 3 pickups. Can you guys see these 3 points are 3 pickups? I'm going to go size the third one, which is the instantaneous piece, that leg. All right, let's go back. Okay, now press, write this one, instantaneous in amps. Here's my formula. Instantaneous in amps equal the settings. I'm going to say settings. Setting multiplied by, which setting though? Which setting you're going to use? The ins setting, N setting. The instantaneous setting multiplied by the plug in amps. The plug amps. Don't ask me why. So let's go apply this formula. Equal. What? Now Chris decided based on the coordination to set this instantaneous. That's based on the coordination 30. 30 is a multiplier. So 30 multiplied by plug in amps. What was the plug in amps, guys? The plug in amps was 1,000. Thank you, 1,000. Not the settings, the plug in amps, and that will get you what? 30,000, right? 3K kilo amp. 30. So this is a short circuit. This means this circuit breaker will trip within 3 cycles if you hit 30,000. Done. So to ace this, all what you guys need to do is write these formulas with you on the test, bring them, plug them in, good to go.
So then short time pickup means?
Short time pickup would be a low level short circuit or a ground fault. I hate to say ground fault because ground fault have their own sensors, but a low level short circuit. Guys, short circuit, there's 2 different. Short circuit, I can grab a phase A, phase B, phase C right at the service, bolt them together and flip the switch. That's what you're looking at right here. Or I can have phase A, phase B, phase C in a 225 amp panel downstream, way downstream, and plug the switch. That's completely different than its value. So it's different based on how far you are from the service. It will get lower as you go farther away from the service. Okay, so we size the pickup. Pickup is always in amps. Everybody can give me a thumbs up, Chad? We understand pickup is always in amps. Okay. Tao, my friend, and Ashley, you guys are good? Okay. Pickup in amps. Delay is always in seconds. Pickup in amps, delay in seconds. So instantaneous pickup, long time pickup, short time pickup, they're all amps. Ultimately, you're going to come up with an amp value. Delay are always in what? You delay time. Delay is always in seconds, which is time. Delay is in seconds, which is time. Okay. Instantaneous time, time to open the circuit breaker. Number 4, we're going to size the instantaneous, guys. instantaneous to open the circuit breaker. How far do I want the instantaneous to wait until it opens the circuit breaker? I decided to put it in 20 cycles. So this is, I want the instantaneous to wait. I know it's called instantaneous, kind of weird when you say delay the instantaneous. I want the instantaneous to open within 20 cycles. Within 20 cycles. My question for you, that's really, there's no calculation in it. So I said instantaneous time to open in, Chris, can you, I don't know if anybody can read my handwriting, in seconds. This should be seconds, believe it or not. In seconds, maybe I should erase it.
That's just kind of a standard 20 cycles for
In this circuit breaker, you can go up to 30 cycles. Yep, absolutely. Circuit breaker in seconds. So really, it's a fancy way, Chris, of telling you, could you please convert the 20-second cycles into seconds? So what I'm asking you, instantaneous time to open in seconds, if the setting is set at 20 cycles. So in a fancy way, I'm asking you, could you please convert 20 cycles into seconds? How do we convert cycles to seconds? You divide by what in the US? 60, not 50, right? So this means you have 20 divided by 60, and that will get you how many? What?
0.33.
0.33. It's just 0.33 what? Seconds. 0.3 seconds. So that's how long will it take the circuit breaker to open based on this setting. How long will it take this circuit breaker to open based on this setting?
It wouldn't hurt to have these example numbers, actual numbers on the diagram.
What did we say? Instantaneous. Yeah. 1, 2. Yeah. I hear you. These are not. They don't match the numbers in the. Absolutely. Long time pickup, long time delay. Because delays are always in seconds, so there is no need for the long time pickup and delay. The only things in cycles is the instantaneous. Okay, any questions about these 5 things I want you to do? The pickup, 3 pickups, and 1 instantaneous convert into seconds. That's all. That's all what I want you to do. Now the question would be, Chris, like he said, matching Chad. The question would be, how about the long time pickup and short time pickup, Chad? What are they? Can we do calculation for these? Here's my question for you. There's really no need for calculation because of the following. Long time delay, the delay, they're set in seconds. So if I say the delay was 5 seconds, what do you need to calculate here? 5 seconds, 5 seconds. Short time delay, the delay was 1 second. What do you need to calculate? It's just 1 second. It waits 1 second, bam, it opens. The only thing that needs some calculation, not really calculation, just understanding, is instantaneous. If you delay it or disable it, they disable them in cycles. Ground fault, I didn't touch on the ground fault, but very similar to it. Any question, guys, about this circuit breaker? So for all practical reasons, really the most important value for you, design-wise, is what we did, this number. This is the single most important because it converts 3200 frame into a 900 into a 900 kcm cable, right? Now, a lot of you, if I ask you to go size based on the frame, you know how many conductors you need to size for 3200 amps? It's a lot of power. Lots of power. Okay, so that's the example I wanted to go through. Now, could you please go to power tools for window? Grab your power tools for window, and I would like to do just one coordination here, guys. Show you. Okay. Were you guys were you able to run the analysis on your circuit? Were you able to run the analysis on yours? Okay. So now you need to build this. Building it, we went through how to build them. Really piece of cake. You need to put the cables in them. When you're done building them, you're going to run balance studies. Remember how we went with Mishad? And the ones that I would like you to run, guys, one more time. You go here, run, and balanced studies. You need to run load flow and short circuit and hit run if everything. I have two warning here. It's warning me. I have two warnings. If you hit error, it will tell you what the warning is. Like I have a cable that has no wire in it. Can you guys see that? And I have two cables that has no wire, and I have a transformer that's not specified. The secondary of the transformer is not the bus voltage, rated voltage. The secondary is not specified. So it gives you a warning, and I'm trying to see where these babies would be. I know I added this one, so okay, so where are me right here? Most likely this is a transformer that causing us this trouble. So if I go to this transformer, guys, and I specify the voltage on the secondary is 208, and the second voltage on the voltage of the bus is 208. I'm fixing my own, and the size of this transformer, I'm gonna just make it 300K, just for my nominal kVA 300, just to do a calculation here. I'm gonna copy the data from this cable into this cable, so I can just do my paste data, and I'm gonna paste my data also here. Copy data. Remember how we said copy data, paste data? I'm just trying to fix mine so I can run some analysis on it. Okay, let's go run again. That guy, the driver, is the runner. Run again, run. There you go. So I thought we ran with no problem, right? So we're gonna go run analysis. Okay, fatal error. Oh boy, what's my? I have 8 fatal errors. That's interesting. Let's go look at the fatal error. What did I do in that click? There is no cables in there. Oh boy, that's a really fatal error. And no cable in this, and no cable. These have no. Can you guys see? There's no. When you click on them, there's no data on them. Let me go populate each one of them by just. If I can. Transformer. Where's my second transformer here? It's the only transform. Is that cable here? Okay, yeah. Bet you the same. Okay, so I'm gonna go, guys. Grab. I just copied. Let me see if there's something in this. Here you go. Here's a cable here. I'm just gonna go copy this cable data. I should have checked. Copy data, and I'm gonna install it in all the cables. Cables here. Right click, paste the data. All right, and my transformer is set at 208. 208. Okay, great. I think I should be able to run my studies now. Let's go run studies. 2 fatal errors still. All right, Chad, what are they? I have a transformer, 208. Oh, the bus is different. Can you guys see? Can everybody see that the bus here? 208, I'm tying a transformer to 2 different voltages. I don't know if you can see here. Mismatch between the voltages. I should have done that from the get-go. Okay. Let's make this is let me see, where am I here? That's the last branch that I did. There you go. This voltage should be 480. And this little dot here, oops, this voltage should be 208 is good. This little dot here, oops, Chad, come on, buddy, old bell. Shouldn't have ran this. Okay, here's a go. This is a 208. Let's wire the transformer. I'm going to go disconnect my transformer one more time and disconnect it. There you go. Transformer voltage is 208. Okay, bus, good. Everything is good here. Oops, cancel. Close this. Grab it here, tie it from one end to the other end. So, okay, it's telling me some mismatch in the voltage, 2.8 here. What's the voltage in the primary? The voltage in the primary should be 480. Okay, 480 in this side, and 480 from this side, and there you go, 208. So what's wrong with you, buddy, old pal? Let's run analysis. See what another fatal error. Two fatal errors. Edit. Transformer. No impedance. Because we did not pick this transformer. So dry transformer. Yeah, okay. So we picked our transformer. Delta voltage. Okay, so alright, so I have to pick the transformer from the library to get the impedance, guys. Let's run one more time. To warning. Alright, edit error. Here's the voltage, should be 208. Okay, that's an easy fix. That's typical, guys, when you run the study and you're getting all hiccup. No fatal error, nothing. Everything is cool. Run analysis. Warning 0. So we should be able to run our analysis. Okay, run. Set load for study setup and press shift. Okay. All right. Let me just do a coordination curve, and see if I can get a coordination curve up and running. Can you guys follow up? Everybody's riser is ready for the coordination curve. What I would like you to do, the first thing is to go to the main circuit breaker that you guys installed, the main circuit breaker, which should be at the utility side. Can you guys go rename it, say CB dash switch gear, right? Because name it by the switch gear. CB switch gear. That's the circuit breaker for the switch gear. Cool. So that's the circuit breaker for my switch gear. Everybody got that one, guys? Name it circuit breaker for the switch gear.
Can I ask a quick question?
Yeah,
about
please.
the circuit breakers? If you double click on them.
Yeah.
And then, do we have to series rate them?
Not now. No, not these.
Okay.
Not these. Definitely not these.
What happens if we did?
Different topic. It's a whole different series rating is a whole different thing. Okay, let me go to the lighting panel. What was your lighting panel, Nick? What was your lighting panel size?
175.
175?
Yeah.
Okay, so I'm going to go circuit breaker lighting panel. Okay, so here's what I'm going to do, guys. I'm going to go click on the main circuit breaker. Are you guys with me? Go to the main circuit breaker that you did. Double click on it. Everybody's there. Double click circuit breaker. Cool. Can I have thumbs up? Yes, no? If you guys do it with me, you finish it today. If you don't, 10 points out of your final on that assignment. So you're going to go library. Click on library. So now we're going to the library of the circuit breaker. Everybody's in the library? One more time. Close this one. Close this. Everybody is at the circuit breaker. If you don't have a circuit breaker, do you guys have a circuit breaker? Everybody has a circuit breaker? No problem. Let's go grab a circuit breaker. If you don't have a circuit breaker, can you guys make, let's just do no circuit breaker. I'm going to go delete the circuit breaker and put a circuit breaker. How about that? Destroy it. Okay. Let me just see. Everybody's looking at something similar to this at the service, right? Cool. Okay, let's go add a circuit breaker. Can you guys see where that symbol here? New low voltage circuit breaker. Cool. Click on this. Now I'm holding a circuit breaker in my hand by clicking on this, right? And then just slam it against that wire. Make sure you have enough room, and not here, just right in here. Cool? So slam it right here. You got yourself a circuit breaker. Cool? Everybody got that? Okay, now we need to rename it. So when you name it, double click on the name and call it CB-SG because it's a circuit breaker main for the switch gear. Okay? Cool? Yes, no, Dustin? All right, okay, now let's go double click on the symbol itself. Double click on the symbol. Now you are in the component editor. Are you guys all in the component editor for the circuit breaker? Phil, my friend, you guys are good? Ashley, Tao? Okay. When you go there, there's something called library. Click on the library. Everybody clicked on the library? Everybody's looking at a library like I'm looking at? Okay, go expand it. You see how to expand this window? Now you're looking at a big window. Okay? Now I want you to do, let's try, can you guess, there's low voltage. Can you see the low voltage circuit breaker? It defaults you to static trip. If you click at the top here, we need to go color hammer. Remember, because this we need to use that Magnum DS circuit breaker that we used. So these are color hammers. So or Eaton, I think it should be. Let's try color hammer first. Here's all color hammer circuit breakers. Everybody clicked on color hammer right here. So now you're looking at color hammer circuit breakers, and Magnum DS. We're looking at. There you go. Can you scroll down? Do you see the Magnum DS? This is the circuit breaker that we were just looking at a second ago in the catalog. Can I have thumbs up that everybody is looking at Magnum DS? If you scroll down, you expand this. Okay, so here's what your option. Your option is, remember, look at this one. This is 3200 amp. What does F stand for? Frame, thank you. What does the P next to it stand for? Plug, thank you. So can you guys see right here? This is where you know where your range is. Okay? So for the main, Chris, for my main, I need more than 3200 amp because I have a 4000 amp. So I'm going to go all the way. You can expand these. I need, let me see if I have a Magnum you see the voltage there too. Let me see a Magnum 400. Here you go. Let's go to this one, guys. Way at the bottom. Can you guys see it? And now, which one to pick? Oh my God, you can spend your career here, knowing what type of circuit breaker. If you guys go, 1 second. I want you to be looking at 600 volt, not any other voltages. Just a 600 volt. Cool. Make sure the voltage is 600 volt. Make sure you look LSI, long time, short time, instantaneous. LSI is long time, short time, instantaneous. That's the 3 components. And right underneath it, I need a frame of 4000. Cool? So that's really the 3 things I'm looking for. The 3 things I'm looking for is a voltage of 600, a short circuit, long time, short time, instantaneous, and a frame of a 4000, and the plugs that comes with it. I don't care about the plugs. We can plug them at, this should give us a lot of plugs. Cool? Everybody got that one? That's the one that we're going to standardize. It's Cutler hammer. If you can't, can you guys make sure that you are clicked on static here and you are looking at Cutler hammer? These are the 3 things, or 1, 2, 3 things that you need to know to find this circuit breaker.
It's the one right below 3200.
Yep, right below 30, but look at the voltage. There's many of them. Make sure the voltage is 600. Cow? Did you guys get it? No? Does it say color hammer here? Okay. Do you see this? Can you click on static trap? Double click on static trap. Okay. Click on that little down arrow. Interesting. You're in the cable. You're looking at the cable. You click on the cable. You're trying to get the circuit breaker. So that's why. So there you go. So you need first a circuit breaker. Next on the circuit breaker. Now we're looking. There you go. Because you're looking at a library over here. There's so many libraries here. We component that it's all libraries, right? Yeah. So there you go. And you're going to go all the way to Magnum. Hammer, Magnum. There you go. And the one that was before is 600 volt. This is what it is, right? Okay.
What's the difference between the 2 that are listed as 4000?
Yes. It's irrelevant at this point.
No, I asked the question, what is the difference?
What difference between what?
There's two that are labeled 4,000
Yeah.
amp. One is,
This is, as I said, it's not really, I don't know.
oh,
The
that's,
answer is in
that's an answer, thank you.
Okay, let's see your, can you find it? Hammer. There's so many guys, circuit breakers that you can find, Magnum, it's such an avatar, you like first always tell me. You're gonna go all the way to Magnum. Yes.
After that,
And
series
you go
number
to-
says 2,000 and 2,500 amp low. The one just below that says 3,200 amp or.
Oh, so we
So
want,
it's
we
a
want the
different
one below. We want
I would think so,
4,000,
because we want a 4,000 amp plug.
That's
No, you don't want a 4,000 amp plug.
because,
Oh. Well, that's a key.
Okay, let me see where we are now. Okay, where are we here, Magnum? Yes. Magnum, yes. 4,000, yeah, 600, right? That's good enough. Okay. Fuse is not working? Got it? Oh, just leave it. Okay. All right, so when you get there, guys, Chris, there's so many of them. For the sake of the time, we're gonna just pick up our 4,000 amp long time pickup. The question with Chris, you were saying, why can't I pick up the 3,200? Okay, here's the difference. If you pick up the one underneath it, then you cannot use that circuit breaker for the 800 amp. The best thing is to give you a circuit breaker that you can have a lot of smaller plugs, so you can plug all your panels, receptacle panels, and lighting panels. Otherwise, if you use this one, this is only have 3,200 amp and 4,000 amp. You might not be able to plug it down into a 400 amp panel. And you can come and change it. So let's pick this one, guys. We need this for the main too. This can go to, we might have to bring both of them. Let's bring, you're right, because of the main, you need to go all the way up to 4,000 amp, where we're picking the main. Can you guys pick the one that says the plug is 4,000 amp, because we need this one for the main? Got that one? Okay, double click on this. When you double click on it, guys, you load it in the library, X out of the library. Everybody's looking at this screen now? Everybody's looking at this screen? Okay, when you go there, your default, can you guys see where default at the top is the frame? What frame do I need? This is all the frames that comes with this boy. I want to remind you, we are doing a 480 volt, so you need one that says 480. And it has to be a 4,000 amp. My two options, Chris, are these two, right? Look at the two options. I have a 480. These are the two options. I use the 85. Start with the lower, see where it says 85K, start with this one. Everybody got that one, guys? Right at the top. That's the interrupting rating. How much is rated for? Okay, let's go to the sensor. What sensor do you think? This is my main. I went to sense. It's a 4,000 amp. Click the sensor. Remember that sensor is? We just talked about the sensor. Sense at 4,000. What's the plug? You have no option for the plug. If you sense here, then your only option is what? It's 4,000. If you sense that lower, then you get different options. Okay, that's the only thing you need to do here. All these settings, I want to remind you guys, the settings that we're talking about, long time pickup. Here's your options for long time pickup. You can go long time pickup between long time pickup. You can go between 0.4 all the way to 1. So let's just go change it to 1. What does 1 mean? 1 times a 4,000. This is a 4,000 amp switch gear. Change the long time pickup to 1, will you? Okay, cool. That's the only thing I would like you to do. And then exit out of this. Okay, now we have created the circuit breaker for the main. I'm going to go to my lighting panel. Can you guys go to your lighting panel? Here's my lighting panel. Before I go to lighting panel, do you guys have a circuit breaker for lighting panel? Thumbs up if you do. How do you have a circuit breaker for a lighting panel? This branch here? Okay. If you have, I want you guys to double click on that circuit breaker for lighting panel. I have no circuit breaker for it. So I'm going to go again and to the library. When you go to the library, yes, Chris. Yes, but But here's the problem with the circuit breaker. What was the size of the circuit breaker for a lighting panel?
Much smaller than our 4,000.
Yes. So you can't use that. You can't copy that particular one because it's way too high. Just because it's way too high. That's the only reason. So for this reason, guys, most of the stuff that we're gonna use as feeders, I'm gonna use this one. If I use a frame, let's use this. If you guys look at this frame, right underneath it, it's a frame 1600 amp frame. Most of the feeders that we have all the feeders are less than 1600 amps. All the feeders out of this panel are less than 600 amps. So instead of using a 4000 amp for the feeders, I put a 1600 amp frame that can go from 200 all the way to 12, what is it? 1250. Can you guys pick this one, please? Why did I pick this one? Because that one is cool for two reasons. Number one, I can go, guys, I can go 1600 amp if I want to, or all the way down to a plug of 200 amp. That will cover the following: your receptacle panel, your bus duct, your everything that you need. Could I have used any of the others and set them up to get me what I want? Yes, but it would be a waste of money. It's a waste of money to use a frame of 4000 amp to get 200 amp out of it. Okay?
So when you buy the frame, it's like the rating of the container. The plug. The higher the rating.
Yes, the frame limit is the plug is the frame. Okay. Does everyone picked up the one that says this one, guys, 1600 amp? Okay. Can you double click on it? Now you double click on it. Double click. You load it to your library. Now, Chris, this is the one I'm going to be copying all over. That's the one I'm going to be copying all over. Okay. So let's look at what my option is. My option is it came with 480. And it's 1600 amp frame, 65 interrupting rating. Can you guys see where the top here? Here's my option. My option are, I really have two options right here. If you guys can see it, three options at the 480 level. We are 480, right? So my option is 65, 85, or 1000. Can you guys pick the 85? The only difference between them is 85,000 interrupting rating. You can go scale it down when you do your calculation. Let's start with 85. Everybody picked up at the top a frame of 1600. Okay, let's go to the sensor. I'm going to go sense. Usually when you guys want to sense, here's my options. Now this is, Chris, this is a lighting panel. What was the size of your lighting panel? 175. Anybody else got up with this? 200? Anybody come up with higher than that? Okay, since we're 200, some of you are 200, I'm going to go pick up the 200, right? Start with 200. Everybody got the 200 sensor? All right, let's go to the plug. A 200 sensor can only go with a 200 plug. I have no option. Okay? Now, the last thing you need to do, the long time pickup, in order to make this is really 200, you need to make the long time pickup what? 1. Otherwise, if you put it 0.4, that will be, say 0.5, that will be 100. I mean, cut it by half or by 40%. Can I have thumbs up, Chad? We got these? Yes, no?
No, my sensors are popping up.
Okay, are you at
480 MBS dash 816 16 85 85.
Yep. Click on the sensor.
Yeah.
That's weird.
Oh yeah, you picked the wrong frame. Okay, there were two of them. Let's go. That's easy fix. Go to the device. You pick just the library. The one we want the one above it. The one that says 200. You see, you're limiting yourself here. You want to pick up the one that says the one that's 200. The frame of 200. Oh, there you go, right here. Okay. Well, but I thought they have them also on the. Here, right here, long time. The 600 volt. Let's go to the 600 volt. There you go. First, and then you are right in there.
Okay, now try now. I flipped it. Okay. All right, no problem. Because you guys, if you pick a different circuit breaker, guys, it limits the plugs. That's kind of a. So the art, just to give you an idea, the art is getting to know the circuit breaker that you need. And that's only with time, really only with time. Why did I pick up this one? Because we use it many times.
Our panel, we have a 175,
Yeah.
So I'll try and
Thank you.
set the 0.8.
Yes, yes. Now we're going to go tweak it down to 0.8. 0.8. Okay, so I'm done here, except now let me go coordinate these two together. Can I get you guys to coordinate? Now let's go coordinate them. Can you do me a favor? Click on circuit breaker, the main, and hold the control button and click on the lighting circuit breaker. So pick both of them. That's, you hold the control button, and so I picked the lighting circuit breaker as well as the main. Okay, everybody's there? You picked both of them. Very essential that you pick both of them. If you did not, we'll get back to it. When you do that, then you're going to go, can you guys see this symbol here where it says go to time current curves, time current curves right in here. Can you guys see that? Click on this. Now all you guys you're faced with a time current curve of nothing yet. We want to call this time current lighting panel, right? LP. So name it LP. So every time you look at it, this is a coordination between your lighting panel circuit and your main, right? So makes sense, LP. And since it's the nothing, it's new, right? So hit new. Are you guys okay? Hit yes for whatever you get. Are you looking at a curve like this? If you're looking at two curves like this, give me a thumbs up, please. Yep. Are you looking at two curves? Okay, so let me close out of that. All right, so are you guys up to, did you pick the two circuit breakers? By holding control, and if you go to this button here, okay, can you guys see it? So click, and then name, type LP and hit new. I need you guys to get this one because we can't move forward unless you get the two curves. Tao and Feld, you guys there? Yes, no? William? Tao, are you guys there? Okay, you guys are there. Feld, do you need help? No, good, okay. All right, so since, for me guys, since I already have one, I just click on it and I'm gonna hit open. Okay, I don't wanna do anything with it. Okay, are you guys looking at curves that looks like this? Right? Now, I want you to look, I know Nick did not say anything about, you can see that they're kind of crammed to the end. Does that bother you? It does bother me. So the first thing you do, I know Nick did not mention that when the first thing we need to do is going to change the scale so you can, all what you're doing is just changing the scale to shift them in. All what you're doing is changing the scale. Very easy. Can you guys see where it says sitting? Way at the top. Can you guys see where it says sitting? Way at the top. And TCC sitting. And all what you have to do is just, one more time. Okay, let's go, you're here, go sitting. And right underneath it, TCC sitting. Click on that one. Do you guys have a window like this? All what you have to do is add a 0. This is axis range. I usually add 1 0 to each range. Okay, to the top and the bottom, so you can squeeze it. Add 1 0 to the top max, to the max 1 0, and also the time 1 0. Did you guys put 0 at the one here? Just 1 0. Okay, look what happened. I'm shifting them this way. Did the 0 actually shift them all the way in? They're still crammed. So let's go one more time and add TCC. I'm going to add again 1 more 0 to each one of them. And here you go. Now if we added 2 zeros from the get-go, you're going to see the end of the curve. Everybody sees the end of the curve? Perfect. Perfect. Now this is, can you guys see that the main circuit breaker here, right here, and the panel circuit breaker? When you remember when we were talking about coordination, if these two curves are touching each other, they are not coordinated. Are they touching each other anywhere? How about the bottom here?
Well, yeah, how do we
Good.
explain the bottom?
Yeah, the bottom is instantaneous. That's all hell break loose. That's instantaneous. When you click on any one of them, guys, the name, you can move the names. I always like to put the circuit breaker name. The one to the right is the main, right? It says circuit breaker switch gear. That's a big boy. The one underneath it is the lighting panel. So the first thing you need to do, go to the main, make sure you click on it, hit settings. Can you guys see that? I put my settings here. Okay, and I'm going to see where it says instantaneous here. Everybody can see where it says instantaneous. Please make sure you are dealing with circuit breaker, switchgear circuit breaker. Everybody, and hit settings here so you can see. Does everybody see the settings here? And the main is a black. One more time. No? Okay. Click on that one. The one to the right. Did it turn black? Okay. Go to the upper left corner. You guys are looking at devices, right? Click right next to it. There's settings. Right? Okay. So here's the settings for this device. I can actually change it right here. All the settings I can change it. Okay. All right. So what I need to do, oops, you can change the color and do a lot of stuff here. So I'm going to go delete the instantaneous. Click in this box until it turns into blue. Can you please? Instantaneous. Cool. So what I'm going to do, guys, I'm going to delete the instantaneous. And I'm going to, where it says, where the heck is delete? Delete segment. Can you guys see, right? Look at my, so click on it until it's blue, where it says delete segment. Everybody saw where delete segment is? Hit delete segment. What happened to your circuit breaker here? To that leg of the circuit breaker? Went up. Now you can drag it. Can you see how you can drag it? You want this one as high as you can. And you start, this is what you're coordinating. You start moving the curve. And feel free to do that. Go grab it. So here's, make sure this is dragged all the way to the end in every segment. So look at my circuit breaker is way to the right. I'm moving it. Do I have a full coordination between these two curves? Do I have a full coordination between these two curves? Yes. I have full coordination between these two curves. How do I came up with this, guys? You can click on this, see how I can coordinate. Every time, Chris, I move this is, look at this. I can change my pickup, the delay on my pickup. These are all, and you can do it here too. You can change the
curves changes the settings.
Absolutely. This is the cool stuff.
The electrician sets the settings.
Yes. I'll show you where you can, the most important thing I'll show you in a second. Why do we, this is graphic, doesn't mean anything until you put it in a report and you give it to the electrician so they can install it, right? So what means a lot is these guys. Let me see if I can highlight
How
this.
did you move your pointers?
Which one?
CDSG.
Let me, before I forget, what's the most important thing is right in here. Can you guys see that? That's the settings they're going to give to Mr. Electrician. So, and actually it comes in a report. You'll see a report. And you give it to the electrician, that's how they go tweak the circuit breaker to fit. Okay, so I'm going to go take a snapshot of this. Clean it. Okay, Chris, I'm sorry, did you get it? What was that? Okay, any question about this coordination? We're done with this coordination. I'm going to do one more coordination, and then the rest is piece of cake. One more coordination. That's done. Now, when you're done, again, this is meaningless unless you go give it to the electrician so they can install it. So you're going to go run. Can you guys do me a favor? Last step. Run. Everybody's there? Run. Can you guys see where it says run? Run. Okay. Run. I need to run a TCC, the last run TCC report. Everybody can see way at the bottom. Run TCC report, the last thing. Chris, run TCC report, the last item. Did you get into a different window?
You have to have the graphical window.
Yeah. Yeah, you have to have the graphical window. If you got out of, okay, say you got out of the graphical window, we're done, right? So I got out of the graphical window, no problem. Can you guys see that little icon here where it says TCC? Click on it. When you click on it, you're going to see your curve that you did. Double click on the curve and open it. So and change or append, replace if you have to. So here's your curve again. Cool. Everybody's at the same curve. All right, let's go. Run the last report. Everybody's looking at that. Run TCC report. Click the TCC report. What do you want to name it? I'm going to name it LPTCC. That's called, they call it TCC because it's time current curves, right? So and hit OK. And here's all the information that's going to run out of it, and OK it. And where do you want to save it? You can save it. It's a Word. This is changed it to a Word document. You can save it anywhere you want, but stay where it defaults to, and hit save. And when it saves, are you guys looking at this report? After it saves, it will ask you to open the report. The report looks like this. Here's the single most important report that you're looking at out of all the yakking that Chad was telling you. Now then, Chris, here's my circuit breaker information I'm going to give to my electrician. My electrician is going to go set the long time pickup at 1, the long time delay at 24, short time pickup at 10, short time delay at 0.5 for the main, and for the one that's feeding the panel, long time pickup 1, long time delay 2, short time pickup 2, short time delay 0.2, and instantaneous set at 2. Done. This is one of the single most important reports that you're going to have. Cool? Don't worry if yours doesn't match exactly mine. And of course has all the information about, can you guys see the plug and all this good stuff? Long time, everything. And also it has the name of the circuit, the device name, the bus that's connected to, how many phases, the voltage, so fault current, tons of information about it. But these are the single most important thing you're gonna encounter. Okay, I promise you, let me do one more I'm gonna do one for the chiller because it's cool, and then I'll let you go eat. Can I do one more for the chiller? You guys have the for that? One easy one for the chiller. Can I have a thumbs up before things start throwing at me? Okay, cool. All right, so when you are here, so go to the X, not the upper X. Can you guys see the upper X will close the whole project? The lower X. Everybody can see the lower X here, and X out of it. You go back to the curve. I don't want the curve. I want to X, the lower X out of it. Do you want to, did I X cancel? I think I hit the upper X. Okay? Any question? At this point, please go save, will ya? Go save. Hit save. See where it says save there? Hit save. Right in here. Can I have thumbs up, Chad? We did the report, we did the curve, and we saved. All right. One more curve for the chiller. One more curve for the chiller. Do you guys have the chiller modeled? Do you have a model for the chiller? No? Okay. Here's what I want you to do. Do you have a model for the main panel? The mechanical panel. Do you have this branch that looks like this? Okay. Mechanical panel 1. Do you have the branch mechanical panel 1, the ones who were with me? Okay. Now let's go clone. I told you it doesn't matter what your belief system, with Chad you're going to clone. So we're going to go right here, pick him up, right to left. One more time. Start here, box them in, right to left. Make sure this is the only thing that's selected are these 3 things. Can I have thumbs up when you select them? Yep. Okay. You're going to right click, hover over it until you see that little cross there, right click, and clone. Do everybody see the clone? And guess what? You don't click anywhere else. Now I cloned them. You guys are cloned. Don't click anywhere else after you clone. Cool? Everybody's there? Okay. I'm going to go grab it. Make sure you hover over until you see that little cross, right? And drag it and put it right in here. You have just cloned a branch that's similar to the mechanical panel. Why did they do that? To expedite the process. That's all. We could. You're absolutely right. We could. Everybody's at this point, guys. Now let's go change it. Start with the circuit breaker. Double click on the name of circuit breaker, please, and call this a circuit breaker chiller. Right? Chiller. Chris, have you noticed that every time we touch anything, we name it? Because when we look at them in the curves, guys, if you don't give them a unique name, you're doomed. You're looking at circuit breaker. What circuit breaker? You have to give it a unique name. Okay, let's go to the curve. Same thing, guys, for the curve. Double click on the curve on conductor and name it chiller. So every time, Nick, do you see why Michelle likes this? You have a documentation of every single feeder in your building. What better than if I'm an owner of a building? You know what we're struggling here at Dunwell to find? We don't know which feeder feeds what. We don't know which feeder we want. We're struggling with how finding the feeders, let alone the branch circuits. So when you do it this way, you have a complete documentation with names for every single feeder. Technically, you can take this information, go tag the feeder with that name, and it tie it to the one-line diagram, and it lives forever. That's how they do hospitals, sport arenas, and so forth. Okay, so the bus, Chris, what do you think the bus is going to be? Chiller, right? B chiller. Okay, I know I'm taking for this sake is just really a node, but I want to make it a bus, so I need to know what the short circuit there. Okay, when you're done here, can you guys give me a thumbs up so I can drop the chiller now?
So pretty much just like a big piece of copper there.
Yes, it's really here. The bus is nothing but a node. But okay, can you guys see where it says induction motor? See where it says induction motor at the top? Everybody can, that icon. Everybody can see with this icon here, a motor, one more time. Induction motor, right? Click on that. Now you're holding the chiller in your hand. You're holding a chiller in your hand, which is a motor. Go attach it to that bus. So I attached my chiller. What do I need to do? Name it. I need to just name it chiller. Okay? I named it chiller. Everybody drop that baby and name the chiller. Can I have thumbs up? I know, am I going too fast here? Okay, sorry, Chris. Okay, everybody guys can see that? Let me zoom in a little bit. Okay, so I have a chiller circuit breaker, a chiller cable, and a chiller bus, and a chiller.
And we don't need to keep that motor part of it, the prefix of it.
M for motor.
Whatever convention we have.
Yeah, I don't know if we did convention for motors though. No, see when we did the air handling unit, we just put the name right here.
No,
Okay. All right, so everybody's there, guys. Okay, let's go. Now, the first thing I need to do is go put the size of the motor of the chiller. Double click on the chiller itself. The chiller, everybody, one more time. I might have one. Go to the chiller symbol and double click on the symbol itself. When you double click on it, you open a window like this. Do you have the window? Okay. Inside it, it's 480. The first thing you need to do, because our chiller is coming as kVA, change it to kVA. And Chris, what was the chiller? 5224? 525 or 520. I thought 520. The chiller was no, 525. You're the man. I should have believed you, doubting Thomas. Okay, 525. Can you guys? Everybody can see 525 kVA. Make sure it's not horsepower. It's kVA. Can you guys change it to kVA, please? kVA. Okay. All right. I'm going to ignore the start and everything else at this point. I'm just going to ignore the whole start, PFD, and so forth. But everybody got that one? Okay. Exit out of it. Oops. Exit out of it, which is the lower X. Now I have my chiller set. My chiller is set. All right. Let's go to the cable. My cable, what size cable do we want though? 3/0 is not going to get us there for this chiller. Whom did they do the chiller sizing for with you guys? What size did you come up with the chiller? Anybody size the chiller? I did size the chiller. Tao, did they size it with you? I sized it with some team. With you? What was the size? You remember? Your cable for the chiller. Remember we went through that exercise? It should... Okay, 3 sets. Here's the 3 sets, and 300 kcm. 300 kcm. Thank you. The chillers, guys, in the room, just across so I change it to 300 kcm, 3 sets. The length, let's just put 50 feet because they're in closer to each other in 2 different rooms. Throw 50 feet. Cool. So I change the cable. Get out of it. What did I do here? I have four single conductors. For the sake of calculation, technically you have to go back and change it to 3 conductors, but just to expedite the process, let's ignore the 4th conductor. Cool? You're absolutely right. You're absolutely right. Okay. All right. Now, since I changed this, I'm going to go run analysis. So before you do anything, go run and balance studies, and you're going to run your analysis. I have something with my analysis. Set load flow study. Setup tab and phase shift settings to be the same as short circuit. I don't know. Why is that? Is it giving me that?
That's all right. You've got less fatal errors than I do.
You have a lot of fatal errors? Yeah. I
Double
think
digits.
double digits. Okay. Okay, we'll figure this out, but I just want to do it for the coordination, guys. I want to get the coordination. To get a better coordination, though, we have to solve all these fatal errors. Fatal errors, guys, you don't have an impedance in the cable. You don't have a voltage for a bus. That's really the fatal errors. Okay, so let's do the coordination. Do me a favor. Do you remember the main circuit breaker? Click on the main circuit breaker, hold control, pick the chiller circuit breaker, and also pick, oh, we didn't have a chiller. Yes. For the chiller circuit breaker, remember the one that we used for lining panel? Okay, right click on it, copy data. One more time. What I'm going to do, guys, I'm going to copy the type of the circuit breaker that we use for lining panel into the chiller because it's the same type. So click here, lighting panel, right click, copy data, go to the chiller circuit breaker, right click, paste data. Did you guys paste? Just to make sure that you paste the data, double click on the circuit breaker, and you should see the settings. And if you go to settings, you should see the settings. Don't worry about the settings at this time. Everybody can see color hammer, guys, magnum, blah blah blah, all this information. One more time. Go to the lighting panel, Chris. Right click on it, copy data. Go to the chiller, right click, paste data.
Pretty much everything.
All of them are going to be the same as the chiller and the lighting panel, except the main. You got it? So that's how easy it's going to be on you guys. Cool? All right. Now, since we have that, let me go. Do me a favor. Pick the main, hold the control, pick the chiller, circuit breaker, and pick the chiller itself. Okay? So can you guys pick? That's you have to have a control. I pick the main. I want to coordinate the main with the chiller circuit breaker as well as the chiller curve, the start curve. Can I have thumbs up when all these are highlighted blue?
We have to change the settings for the chiller.
We will. We're coming. We will. Yep. We will do that in the coordination. Are you guys all highlighted? Cool. Let's going to go to the TCC. Can you guys see what the TCC is? Where it says go to TCC, click on this. Now, what do you think I'm going to call this curve? Chiller. You got it. Chiller. And you're going to hit new. Right? Name it chiller and hit new. And just hit yes. And you got yourself, my friend, a circuit breaker. Look how it's ugly and distorted it is, right? Is yours as ugly as mine? Like this? Okay. The first thing I want you to do is, Chris.
I was just wondering about that.
Yeah. Okay. Do me a favor. Hit the device. Here's your device. Always go to the settings. Make sure this one is set at the settings so you can see the settings here. Okay?
I don't have a green one.
Yeah, why did we choose the chiller?
Because we're going to coordinate with the start curve. There's a start curve for the chiller. We're going to make sure that the circuit breaker is going to allow the chiller to start.
Oh, because the inrush.
Yes, you got it. You don't have a... Who does not have a start chiller curve? Okay, if you don't, this means you didn't put information in the chiller yet. Okay, go back to the chiller, double click on it. Does your chiller have a voltage and a kVA? Okay. Does it have a voltage and a kVA? Does it? Okay, here you go. Does it have a voltage and a kVA? If it does, now save it. When you're done, exit out of it. Now, let's go back to where we were. Click on the TCC. Now you already have the chiller. Can you guys see where the chiller is there? Double click on it. It should show. Alaribo, you see the chiller curve? Okay. Tao, do you guys have the chiller? Jackson and William? Phil? Okay. All right, cool. Now do me a favor, go to settings here because that's always be in the settings. Can you guys see the settings here? Okay. Okay, cool. Now this is my settings. The first thing you need to do is, because is your curve, guys, way away? You barely can see it. So this is a hint of scaling. We need to scale it. So go to settings. Can you guys see all the way up to settings and TCC settings, and add 2 zeros to the max. Current axis max, add 2 zeros. Oops. Add 2 zeros. And I liked also the time to add 2 zeros. And hit N, and it shifted them all the way up. I think 2 zeros might be too much. Does yours shift it this way? It doesn't matter. It's only these 3 curves. And hit OK. Go one more time. Is your curve, guys, sitting like mine now? You don't have the green one yet? Okay, you don't have the green one. Here's what you need to do. Go back, pick the chiller, click on it like this. Okay? Go to TCC, click on TCC here. See that one? Audible. Click on this. And go to chiller and double click on chiller. It will load it into your chiller. It will load it into your chiller. Do you see the curve? The green curve is very important. If you don't see it, we defeat the purpose. How do you have it? Audible. You did not put information in your system. Let me see.
Alright, that one. Where's your chiller here? Okay, 480, blah, 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 okay. Okay. Okay, we picked it up. TCC. Chiller. There you go. You see it now? You just didn't load it to that.
Okay. All right. So, can I have thumbs up, guys, that we're there? We're almost there. Almost there. So we're going to go to enlarge that one. Now, Alaribo and everybody else, if yours is shifted to the right, remember what we do. We go T settings, TCC, and add 2 zeros into this area. Don't do it yours, but add 2 zeros here and here, and then that will scale it down. You don't have to add it in both. You could add it in the x-axis only. Okay. The first thing, Chris, you need to do you remember that circuit breaker? That's the main circuit breaker. Do we need to mess with the main circuit breaker? No. Why? Because the main circuit breaker had been coordinated with another curve. You mess with it here. Guess what's going to happen to the other curve? You screw up the other curve. So anything you coordinate, the main has been coordinated. So leave it alone. What I need to here's what happened. This is the circuit breaker, guys, that you're using for your chiller. The second one is your chiller. This circuit breaker will never allow the chiller ever to start. Can you guys see how this is the amount of current right here that the chiller needs to start, and this is the amount that the chiller needs to run, and this is the amount the circuit breakers allow it to do. So definitely your circuit breaker is screwed up. So let's go set the circuit breaker. Click on the chiller circuit breaker, guys. Everybody click on the chiller circuit breaker and go to settings. I need to change the sensor. Now I'm going to go pick up the largest sensor, which is 1250. See how it when you pick the 1250 shifted it all the way to the right. I'm going to continue with the 1250 as a plug, and then everybody can see that. Now there's no problem. My circuit breaker is going to allow my chiller to run, but it will never allow my chiller to start. Can you guys see that? The green curve is the start curve for your chiller. Your chiller would never be able to start, but if it's running, it will continue running. So what you need to do, come over here, see where it says that instantaneous. You need to shift it. Can you guys see what I'm doing? I'm shifting it to the right. Shift to the right. You have to clear the green. You have to clear the green without touching the red. Can you guys see that? So this is as good as it gets. So I have my main coordinating with my circuit breaker, and my circuit breaker for the chiller is allowing the chiller to run. Okay? Do you guys have a curve that looks like this? Okay. Now let me give you a couple of tricks here about curves. Now look, Chris, this is where it becomes really interesting. You can zoom out in and out of that. This is where it becomes really interesting. I can grab the top here, and I move it right slightly here. And that will change the settings. So I actually can put, yes, it's 1250, but I can dial it down to 0.6. What's 0.6 of 1250?
When you're saying 1250, are you saying the overcurrent protection device?
size of it?
Yes.
Because we came up with like a 1200.
Yep.
So, okay.
But hold your horses. See how if you have do coordination, you can get much lower than if you're doing it by the code. Much lower than we're doing it by the code.
So right now you're doing high.
Yes. 12. If you guys, we came up with 1200.
Yeah.
Okay. Here's what you came up with. Oops. Right. Here's the 1200 for the most part. Right. 1250. 1250. Here's what you came up. Here's what the code allows you to go. Right. This is what the code allows you to do. But if you have a coordination and you know the information, I can go dial this down, all the way down slightly here, and that would be 0.6. So let's do this one. At 1250 times 0.6, I can set this circuit breaker at 750, and it still allows my chiller to run. Let's see if it allows the chiller to start, Chris. Does it allow the chiller to start at the bottom? Yep. So I can move this one. Now, look at this. Do you think my chiller is going to start if I move it this way? No. So what I need to clear that little edge, and I need to grab it all the way close, but not. Okay. This is what you're looking at, is as close to a perfect coordination as you can get. So let me tell you a few things. When you have a chiller and a circuit breaker that protects the chiller, you need the circuit breaker to be to the right of the starting curve of the chiller, but not far away from it. Very, very important. If you look at this, you guys look at this right here. Can you guys see how this is very close to it, but not overlapping? It's also allowing it here, allowing the motor to start. Can you guys see that? These components? Yes. Yes. Now, could I have gone, look, this is very good point, Nick. Now, I could have gone by code and went to 1200 amp. 1200 amp, right? If I don't do coordination, I can go as high as 1200 amp. Which we did, Chris. We did 1250 as a sensor, though. But we tweaked them down. We tweak it down with the setting to 0.6, and we still allow our chiller to run. Now, if our chiller doesn't run, guess what's going to happen here? You're going to go to this one and change it into a different reading. Say the 0.6 to whatever, right? To go to 0.7, 0.8, 0.9. Okay? When you do coordination, guys, for a chiller with the service, two things you need to keep in mind. Two things, allowable. Number one, the main circuit breaker and the chiller circuit breaker shall not touch each other. Did we get this one? Are they touching each other? No. Second, you need the circuit breaker and the chiller start curve. The green is called chiller start curve. The green curve is called the chiller start curve, right? Remember the start? The start curve. You want the chiller start curve and the chiller circuit breaker to be as close to each other, but not overlapping. Not overlapping. So for example, this is a good coordination. Let me tell you at a coordination that's not a good coordination, still coordinating. Take this neck. I'm going to coordinate. I'm going to take this one, put it right here. Do I have coordination here?
Yes.
Is this a good coordination?
No.
No. Why? Because now, if your motor doesn't start here, it will sit here, cook before the circuit breaker wakes up. You want to allow the motor to reach this point here, start. After, if it doesn't start, this means it's stall motor, and you need the circuit breaker to trip, locked.
Can you just explain the y, the x and y axis?
Oh, thank you. Yeah, very, very good point. Let me zoom on the x-axis. X is time, y is time. All what you're looking at is seconds. This is, what is it, 10,000 seconds. And the x, the y is time. The x's are amps. So for example, very good point, Nick, here. Let me try to zoom in. So you're looking at here, 10K multiplier by 1. So this is actually a 10,000 amp. This is, 10,000 amp. This is 100,000 amp. These are amps. Let me clarify here. So here, in this case, these are amps, and this one is time in seconds. Okay. Let me tell you an interesting thing. If you guys look at this point, this is 0.01 second up to, let's just say this was 0.2 0.05 of a second. At 0.05 of a second, if I have a short circuit right here, Chris, 100,000 kcm, kilo amp, 100,000. This will sit in the system up to 0.05 of a second. And then it will open. That's what they call it, instantaneous. Okay? But if I have a ground fault, look at this. If I have a fault right in here, 1,000 amp. Here's a 1,000 amp fault. Right, the fault. That's a 1,000 amp fault. 1,000 amp fault will sit here and will clear in 100. What would that be? This is 100 to 1,000, so 300 seconds. Give or take. Huh? It's a long time, but it's 1,000 amp on a frame of 1250. That's why, guys, that's why they have a ground fault sensors.
So that's like
Divided by 60. Yeah. Yep. Yep. Yes. You're allowing, but remember, you were sitting, the sensor is sitting at what? 1,000 amp. The sensor is sitting at 1,000 amp. So 1,000 amp is, 1,000 amp, guys, in a 1,200 amp circuit breaker is a load, not a short circuit. Anyway, so that's what these curves give you. Any question about this curve and coordination?
Actually, it's down to 750 because of that setting, that 0.6. No?
Yes, yes, absolutely. Yes, yes. So that's why if you leave it at 1200, if you leave it at 1200 amp, that circuit breaker wouldn't even see it. Take this. See the same circuit breaker.
Why isn't there a break at the current value?
Look, can I just do one little thing? If you move it all the way to 1250, and if you have, do you think this is going to pick? Look at this. It's going to continue forever. So I have a ground fault here. Small ground fault that sits there forever. Why? Because the circuit breaker is sitting right now. This circuit breaker is sitting at what? 1250. Can you guys see why they have a ground fault sensors? Because it's high, but not high enough to trip. It can be seen as a load.
So that curve does not reflect the settings in a way. The setting.
No, that can reflect the settings. I just moved it. Look at my setting right now.
Oh.
I changed it. I changed it.
But I mean, I have mine set at 0.6.
Yep. Yep. So
Yet the current value is well over 1K. Over 1,000.
So if you click this one, drag it all the way to 0.6, like you said, the pickup value here, if you hover over it, it should give you the pickup value right here. Can you guys see where it says at the bottom here? It says 810 amps right at the top of that black curve.
the breaker's rated at 10K.
Not really.
Not really.
Our breakers are rated at 85,000 amp.
Also, it's just the graph is.
Okay. So, any question, guys, about this? So what we need to do is we need to now, everybody got a curve that looks like this, right? I need to run a report so I can give it to the electrician. So I'm going to go run a TCC report. Everybody's there? Run TCC report. Now it's called chiller. It's the name of it, chiller. What better than that name? And it tells you, is this what you want in it? Yep. Hit OK. And where do you want to save it? With the other reports. And it will open it for you. And when it opens it, this is all the information that you got about circuit breakers, so you can give to Mr. Electrician or Mrs. Electrician so they can install it. So then Chris, here's my main circuit breaker. Here's the chiller circuit breaker. Can you guys see what a chiller circuit breaker? And here's the settings that my electrician is going to be looking at from us, so they can adjust the settings on the circuit breaker. So I have right now, and this is what you guys did with Chad a second ago when you were multiplying 0.6 by the plug and so forth. Okay. Any question, guys, about this report? This is another report that must be in your. You guys need it in your binder. Okay, so you have two reports, X out of that report and X out of this. And now you're down to your your one-line diagram. Can you guys see that one-line diagram? I can have tons and tons of information about it. I want to remind you what I need from this software, guys, are listed on project information. I need you to print a bunch of things from this software as we go through. Coordination curves. So we did two coordination curves, one for the chiller, one for lighting panel. This is really as ugly as it gets. I would like you guys, I usually ask for a bunch of other things, but okay, let me see here. If you guys go to the sheet that I gave you, the project sheet, it will tell you, this is sheet number 3 in the project. It will tell you what I want you to do in this software, power system analysis. I need a one-line diagram 11 by 17. This needs to be printed in 11 by 17, one-line diagram. We need a short circuit report. So when I ask you guys to bring to print this one, we should be able to come over here, and here's your one-line diagram. You adjust the print. I think if you print over here, you can adjust your paper and property and all this stuff and print 11 by 17. Piece of cake. Okay, so that's the first thing you need to print. Close it, depending on where you are. So that's the first thing you need to print. The second thing, you need to print short circuit reports. Can you guys see these ones here where it says reports? Everybody can see this icon here. Click on it and text reports. These are all the reports that I would like you to print for me. All the reports I would like you to print as a proof of doing it. Okay, here's the short circuit report, Chris. It starts with SC, short circuit report. Input report, it says input report, Chad. I need load flow report. It's right here, and it's as easy as double click on it, guys, and print. It's not a Word document, some type of a Word document, and you click it. Then I need you. So these are the short circuit report, input report, load flow report, one-line diagram. Then I need you to do coordination curve for the chiller and coordination curve for MP. Instead of MP, can you see it? Instead of, guys, it says coordination curve MP, can you say LP, because we did an LP, just to make it easier for you.
It says MCC.
MCC, cross the MCC and put L lighting panel, LP. Okay? Can you guys cross it? This is in page 3, and instead of it says coordinated curve MCC, we used to put an MCC at one time, we moved it out. So we're going to make it lighting panel, LP. LP. The same thing, you need the curve, and you need also the report. So the report, Chris, is here's the report. We ran the report right there. I'll show you how to print the curve. And I also want you to do the chiller. Can you guys see where it says the chiller? Here's my chiller. Did they run the chiller? Yeah, here's my chiller report. Okay? One more time. So you guys going to do one for the lighting panels, already done. But you need to massage your numbers now and build the one-line diagram right. And one for lighting panels already done. If you followed with me, yours is done. What we've done. Okay, so this is how you print them. And I'm going to just click on the chiller here. And Chris, when you click here, you hit print and up it goes. Here's your report. You hit print view and you hit the
report icon you did earlier.
Oh, I'm sorry. Here, right here. Right here. Okay. All right. Text, then you go text, and here's all report. Everybody knows how to print the report from this software. I'm going to be around. You can ask me too. Okay, so this is all your software. The second thing is close out of this, TCC curves. Click on TCC. Can you guys see this icon here? Click on this icon. I'm going to go to the chiller. Double click on the chiller. Say replace. There's nothing to replace anyway. Hit settings. Everybody's there looking at the curve that we have just, the beautiful looking curve that we just did. We need to print it. I want you guys to print it for me colored. So how do you do that? You come over here, and here you go. There's your print view. That's how it's going to look like. And you hit the print, assign a printer for it, and off it goes. Dustin is very important for you because you're going to take these. I can help you take a snapshot and put them in your presentation when you present about the project. Dustin is going to be our power tools for window expert. Okay, see how easy that is?
From the diagram to print.
Right here.
Hit the printer.
Yeah, you can hit the printer. I usually go print view because I don't want to print.
Okay.
And this is where you can set your printer, put your name, your team's name, adjust, do whatever you want to do. And if you hit print, off it goes. Any question, guys? So with this software, we were able to do coordination. We were able to run reports for the coordination. We were able to build the one-line diagram. We were able to run short circuit and load flow. And Dustin, you're laughing because garbage in, garbage out, Chad. Mine has a lot of garbage in it yet, need to be clean. But my point is, guys, you can run all these. It doesn't matter what the outcome is. What matters is the process. I know how to run it now. You want to spend now, moving on, you're going to spend some good time make sure your one-line diagram is right, as the voltage is right, the length is right, the feeder is right. That's all. And then, but the process is the same. If I put a feeder, guys, 500 and it's supposed to be, say, 300, it will give me some data. It's not the right data, but you know how to change it. Go to your calculation, change it to 300 or 500, whatever it is. Any question? If we have time, guys, I know not today, I can show you how to run Arc Flash out of this software. That's the only component I would like to do. That probably be most likely next week. Any question? What you got, guys, is enough? Is it enough to get you up and running? So what I need you to spend, the 2 curves that you've done with me, you're done. If you want to do more curves, we do tons of other curves, Chris. Coordination. If anybody want to exercise, I can do a coordination. Let me show you another coordination that you can do. I can do a coordination between all these. Here's one curve, and I'm calling this this will be, in my case, I think receptacle panel. This will be a receptacle panel curve. I can do a coordination for the air handling unit. Take this. This is a beautiful coordination. I can coordinate the air handling unit with the main, with this. Can you guys see that coordination that's going to happen? I can coordinate the air handling unit, this curve, with this. Well, let's just do the overcome protection devices. So look, that's another nice coordination. If anybody want to do it, optional. Here's the air handling unit. Here's the overcome protection device for it. Here's the main for the mechanical panel tool. And here's also the main. So these have to be coordinated with each other. All these devices have to be coordinated. And we will call this is air handling unit dash R3 or something. Here's another curve that you can do. Piece of cake. Dustin, the same way that I did them, you pick these devices one at a time, make sure they're filled with information, and you shoot them to the TCC and call your report air handling unit R3. Any question, guys? Any question? If you know this software, you have just add to your reservoir of knowledge and your job survivability in this field another 15%. I'm not kidding you. Especially if you work for an engineering firm. If you work for an electrical contractor that they don't have any engineers, you might be the engineer who's going to do it. Any question? Engineering firms, guys, make a lot of money. We do studies for hospitals, Mayo Clinic. You charge them for $40,000, $50,000 to do studies like this. Okay, so I hope this is enough, guys, for you to build. So moving on, what I would like you guys is to exactly your riser. When I look at your riser in Revit, it should reflect exactly your riser in AutoCAD. And I can help you add the rest and then run the analysis. If you have fatal errors like my friend Nick, we will adjust it. It's just a matter of a switch or so forth. Thank you for listening to Chad.
Yeah, Chad.
Yes, sir.
We don't have the EC 192 on the license. Do we put it on the existing?
The EC, yes. Put them in the chiller. Yep. Thank you.
Oh, thank you.